Kia ora and welcome to a video all about alcohols. So here we go. Here's just some things to kind of get you going to start with. I want you to have a go at naming these ones, then writing a combustion equation for ethanol, and then finding the empirical formula of an alcohol that is found to contain 60% carbon, 13.3% hydrogen and 26.7% oxygen. I expect the first bit here will be easy, this bit will be harder, and most of you will probably completely and utterly struggle with the last one. This is something I expect Year 12 students to be able to do. But yeah, I find that these days people don't tend to be able to know how to do that. So what I suggest you do is pause the video, have a go at doing those, and then come back and I will take you through how to do it. Right, so naming those alcohols. Wrong one. That one. Name those alcohols. This, of course, is 1, 2, CH3, CHOH, CH3. If you like me and you like to draw it out so you can see it, it's fine. So it is methyl prop and 2O. This one here is CH3, CH3, CH2, oops, CH2, 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 OH. This is where I'd love one of those handy little hydrogen stamps, stamp everywhere. That'd be quite cool. Right, so meth, eth, prop, bute, pentan 1-ol. One, two, three, four methyl pentan 1-ol. Cool. Last one, CH3, CH3 twice. Ooh, it must mean there's a CH3 up and a CH3 down, and then a CH2, CH2OH. Cool. Meth, eth, prop, bute. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The longest chain is 4. Bute and 1-ol. And it is 1, 2, 3, 3, 3. Dimethyl butane 1-ol. Gosh, that looks messy. Never mind. Combustion equation for ethanol. Right, here we go. Let's get into some harder stuff. So first of all, what is ethanol? Ethanol is CH3, CH2, OH, meth, eth. Yep, cool, sweet. So this plus something is going to make something else. Combustion equations you always assume are going to be complete combustion. So that is O2, and that will make carbon dioxide and water. When you burn stuff as a fuel, it makes carbon dioxide and water, unless it is incomplete combustion, and then it makes carbon monoxide and maybe some carbon, some soot. Okay. Yes, I should have all states in here, but I'm in a rush here. Okay. So now what you have to do is balance it. So we have 2 carbons here, so it must mean we have to have 2 carbon dioxides. We have 1, 2, 3, 4, 5, 6 hydrogens. So probably going to have 3 waters. Let me just take a choice to make sure I'm right. 1, 2, 3, 4, 5, 6 hydrogens. 3 times 2 is 6. Fabulous. Okay, so now we have 1, 2, but we also have 1O here. Now, of course, whenever you do combustion, it means you're burning 1 mole of this thing in oxygen to make this. Always assume there is the big fat 1 in front of this. Okay, so this means you can have half of this. So it's strange, but it's just the way it does it. Okay, so we've got 1, 2, 2 times 2 is 4 oxygens, and over here we have 3 oxygens. And over here we've got 1, 2, 3. Okay, so I have a total of 7 here. 7 oxygens. So if I had 3 here, then that would make that 6 oxygens and 1 oxygen, which equals 7. Yay! And that's all good. That's fine. Right, the last one, which is by far and away the hardest. And you guys probably will be, after I show you, oh yeah, that's how I did that. Okay, so you start off with saying the statement, in 100 grams of this alcohol, I will have 60 grams of carbon. I will have 13.3 grams of hydrogen, and I will have 26.7 grams of oxygen. Now, what can I do if I know the grams, and what else can I look up? Oh yeah, that's right, Mrs. Hay, you can look up the molar mass. Molar mass. Molar mass of carbon is 12 grams per mole. Yes, I did just say that off the top of my head. Molar mass of hydrogen is 1.0 grams per mole. And molar mass of oxygen is indeed 16 grams per mole, 16.0. Be pedantic here. Grams per mole. Sweet. So, if I know molar mass and I know mass, what can I figure out? Yes, Mrs. Hay, that is right. I can figure out number of moles, mass over molar mass. So, this would be 12 divided by, nope, other way around. 60 divided by 12, which will equal something. This will be 13.3 divided by 1.0. I can do that one in my head. That is 13.3 moles. This one here will be 26.7 divided by 16.0. And just pause for a second. By the wonders of pausing, look what I've done. Right, so this is 5, 13.33 and 1.66. That might seem like utterly, completely and utterly ridiculous numbers to you, and you are right, they are. Those are all moles. So now what you do is you find the molar ratio, because empirical formula is your simplest ratio, of carbons, hydrogens, oxygens. So you find the mole ratio. To do that, you take the smallest number and you divide everything by that. So the smallest number is 1.66. So 1.66 divided by 1.66 is not surprisingly 1. 13.3 divided by 1.66 is momentarily 13.3, nope, 3 divided by 1.66 equals 8. Close enough to 8. Going to make some squiggly lines. Close enough to 8. Right, and then 5 divided by 1.66. Pretty much close enough to 3. So my ratio is C, 3, H, 8. Oh! Of course, it might not actually be that. It might be C6, H16O2, or any other one that actually comes down to that ratio, but that is the empirical formula. Right, cool. Enough of a little sideways journey. Let's go back to the actual thing here. Right, second thing there is to draw and classify these alcohols. So classify as in primary, secondary, or tertiary. I will let you do that. You pause it now, do it, ask me in class, and I'll tell you if you're right. Okay, are alcohols polar or non-polar? Small alcohol molecules are polar, and the presence of the OH group means they are able to undergo intermolecular hydrogen bonding, which we will get onto later on. The large difference in electronegativity between the O and the H atoms means the OH bond is very polar, and the slightly positive charge on this hydrogen atom attracts non-bonding electrons of oxygen on another molecule. Let me just do a quick little diagram to show you what I mean by that. Okay, so you have OH, and this is connected to a carbon of some description. Alright, this here is partially negative, this here is partially positive due to the difference in electronegativity. So we say that the electrons are down that end if you want to do that one, if you're used to that. That's what that looks like. So it means that this hydrogen here, if I had oxygen bonded to, missing all my diagrams around here, it's all good. So this here is H2O. This hydrogen can attract itself to a lone pair of electrons in water. That's what this is saying. Okay, so have another read of it and that diagram might make some more sense. Cool. This means that if small alcohol molecules are highly soluble in water, you think about the ethanol that is in wine, you don't see it floating on the top. It doesn't happen. However, as the length of the non-polar hydrocarbon chain increases, the soluble in water decreases. So as more carbons you have in a chain, the less soluble it is. Generally around butanol it goes all pretty bad. But aqueous solutions of alcohols are neutral. They are not acidic, they are not basic. Presence of the OH group in the molecule is not the same as the OH minus in sodium hydroxide, which is an ionic compound. This of course is covalently bonded, it doesn't make a difference. Alright, we might make another new video on how to make alcohols next time because I'm running out of time. Cool, okay, hope you enjoyed this. I'll see you next time. Bye.